We use the internet pretty much every second of every day, right? But how often do we actually stop and think about how it works? Well, that's what we're going to do today. We're going to take all the technical jargon and turn it into a super clear, visual journey to see what's really going on behind the screen.
Okay, so let's kick things off with a question that honestly feels like pure magic. You click send on a message, and poof! Less than a second later, it shows up on a screen on the other side of the world. I mean, how is that even possible? It's not magic, of course. It's some seriously brilliant engineering.
So, to get our heads around this giant global thing we call the internet, we've got to start small, like really small. We need to look at the simple journey of data from point A to point B. Let's break down the absolute fundamentals of how any two devices talk to each other.
When you really boil it down, data communication is just this. It's an exchange of information between two devices using some kind of medium to connect them. I mean, you could think of it like the classic two tin cans and a string, just, for the digital age. It's that simple at its core.
And this image here, it's perfect. It shows the basic path that literally all data takes. It starts at a source, gets packaged up by a transmitter, zips through a system, gets caught by a receiver, and finally lands at its destination. Seriously, every single email you send, every video you watch, it all follows this exact same path. Okay, so for that journey to actually work, you need a few key ingredients. Let's take a look at the 5 essential things that have to be in place to make this whole communication thing happen. And it's all pretty intuitive when you see it laid out, right? First, you need the message itself, the actual info. You need a sender and a receiver. Makes sense. Then you need the transmission medium, that's the physical path, like a wire or fiber optic cable. And last, but honestly, this is the most important piece of the whole puzzle, you need a protocol.
So what's a protocol? It's just a set of rules that everyone agrees on. This quote nails it perfectly. I mean, if you only speak French and I only speak Japanese, we can stand in the same room, but we can't communicate, right? A protocol is that shared language. It's what turns a bunch of electronic noise into an actual, understandable conversation.
All right, so what happens when we start connecting more than just two devices? Well, that's when we get a network. And the specific way we arrange all those connections, kind of like the blueprint for the network, that's called its topology. First up, we've got the mesh topology. And just look at it. It's this incredibly connected web where every single device is connected directly to every other device. The analogy is perfect. It's like having a private road from your house to every other house in the city. No traffic.
So the upside here is pretty obvious, right? This thing is super robust and really secure. If one of those links breaks, no big deal, the data just finds another way to go. But, and it's a big but, the downside is huge. Can you imagine the amount of cable you'd need? It's insanely expensive and just a nightmare to set up.
Okay, now let's look at something way more common, something you probably have in your house right now, the star topology. If you've got a Wi-Fi router, this is exactly what you're using. Everything connects to one central hub. Now, this setup is way cheaper and a whole lot easier to manage than that crazy mesh network. If one connection fails, it only affects that one device. The rest of the network is fine. But it has a massive Achilles heel. That central hub. If that thing goes down, the whole system is dead. The entire network is gone.
All right, next up, we have the bus topology. Just imagine one long cable, the backbone, and every device just taps into it. It's like one main street, and all the houses are connected directly to that single road. All the traffic, all the data shares that one path.
The big appeal here is that it's simple and cheap. It's really easy to install, but trying to find a problem on one of these, oh, it's a total headache. And even worse, if that main backbone cable breaks anywhere, the whole network can get sliced in half. Everyone's offline.
So why are we talking about all these different blueprints? Well, here's the key takeaway. These topologies are the fundamental building blocks for all networks, from the tiny one in your home office to the massive one that stretches across the entire planet.
So you start with a LAN, a local area network. That just covers, say, your office building. Then you connect a bunch of those together to make a WAN, a wide area network, which can span a whole country. And then, what happens when you connect all of those networks together? You get an internetwork, or, what we all just call the internet. But that brings up a really massive question, doesn't it? How on earth do billions of devices on millions of different networks, using all these different topologies we just talked about, how do they all speak the same language? The answer is simple, but powerful. A shared rulebook.
See, the truly genius solution to this insane complexity wasn't to try and solve one giant, impossible problem. It was to break it down into a stack of smaller, totally manageable pieces. We call these layers, and each layer has one very specific job to do, and it doesn't worry about anything else.
The absolute best way to get this is to think about the postal service, right? When you send a letter, all you care about is writing it and putting the right address on the envelope. That's a high layer. You're not thinking about the engine in the mail truck. And the mail carrier, who's working at a lower layer, they don't care what your letter says. They just need to get it to the right mailbox. Each layer just does its job and trusts all the other layers to do theirs.
Now, in the world of computer networking, this whole layers idea gets official. It's called the OSI model, and it's basically a 7-layer master blueprint that maps out every single step of communication, all the way from the raw electrical pulses on a wire right up to the app you're clicking on your screen.
This slide does a great job of showing that journey up the stack. See how it starts at the very bottom with the physical layer? That layer is just about the raw ones and zeros, the bits. But as you go up, each layer adds a little more smarts, a little more function, until you get all the way to the top, to the application layer. That's where you live, in your web browser or your apps.
So that 7-layer OSI model, that's kind of the official theoretical version. In the real world, the internet actually runs on something a bit more streamlined called the TCP/IP model. It basically squishes a few of those layers together, but the fundamental idea, this layered system where everyone cooperates, is exactly the same. This is the rulebook that's actually running our digital lives.
So what does this all mean? The big takeaway is this: the internet isn't a cloud. It's not magic. It's not even one single thing. It's a massive global agreement. It's a coordinated human effort built on a shared set of rules, a protocol, that lets all of our individual, separate networks talk to each other and act like one. It's an agreement. And that really makes you think, as technology keeps evolving, what's the next big rule we're all going to have to agree on?